Stream information day 11. Always forget that. Disable preview. Alright. So, we're at a point where I need to be able to identify the textures in the atlas. So let's see. Yeah. So presumably the IDs will just be indices into the atlas. Like, we don't need strings. We know what resources we have, so we don't really need strings. So it's something like atlas ID, you know, something like this. Atlas ID, right? And I guess these should just correspond to file names. So like that. Just, I mean, keeping these synchronized is gonna be an experience. But, yeah, well, we'll see if we can avoid it. String memory, Sprite, misc. Yeah, I'll just put that in here for now. Type def enum atlas ID. And yeah, so these will correspond to file names without the extension. Maybe this should be generated automatically somehow. Generate auto generate question mark. Well, right now we don't need to auto generate it, so this is fine. Okay, and they just started, well, commando is with 0, so, alright. Okay, so this is where the atlas is created, essentially. Okay. I mean, I suppose at this point we kind of know how many textures we have, so we don't even really need this. Like, we don't need capacity. We can just say, well, the length of this is atlas ID count. Just that. And then we just allocate the length for the textures. And then, so our push, okay, so our push will not be in our push, it will be textures this ID equals texture. Of course, what is this ID? Well, in this case, the file name will just tell us. Yeah, the file name will just tell us what the ID is. Atlas ID, this ID is, well, if name yeah, I mean at some point, yeah, we're gonna have to if name str starts name with what commando, then this ID is so yeah, if we're gonna auto-generate that enum, we might as well auto-generate this somehow. Although, hold on, isn't this just a lookup? Like name ID map is I mean, it is a lookup, but it's a reverse. It's a reverse one. Yeah, well, we kind of have to do the string compare anyway. Yeah, at some point someone has to do the string compare. Auto-gen. So if it starts with that, then okay, so we need that string starts thing. Static bool str starts str string start well, I mean, if str lang is greater or equal to start lang, bool result is false. The result in this case is memak. Mem equals a string pointer start pointer start length. Return result. Okay, memak, of course we don't have that. Static bool memak is void star pointer 1, void star pointer 2, and I mean, this is just a mem compare, right? So, and what, I64 memcomp pointer 1, pointer 2, lang, and this is an int, memcomp result is that, and then bool result is memcomp result equals 0, I believe. Return result. Let's see, memcompare. What does memcompare actually return? My God, is there? Well, I assume this is the same interface, right? The negative value means different. 0, if they're equal, positive value means different. Yeah, so 0. Okay, so that's memek. Find data, see file name. Yeah, we need to know how long it is. Str name, str is name, strlen name. I think it's just that. Else if so, this would be Lemurian. Yeah, I should probably just do that. But yeah, you can kind of see how these are gonna be essentially the same. And so on. And then else, assert, and recognized file. Alright. Let's initialize it, I guess. So it would be textures pointer. That compiles. Does it run? It runs. Okay, can we use it? So if we switch these around, so both of them are Lemurians. Yeah, I mean, that does work. Okay, well, this is approximately how these IDs would work then. I mean, would they though? Hold on. So I'm pushing it into this array. But then I'm looking up into a different one. Now that doesn't make sense. Yeah, this is Atlas locations, that's different. Yeah, like if I hold on, we can demonstrate the problem, I think. If I just switch these around, we're supposed to see a commander and a Lemurian. Hold on. There we go. We're supposed to see two commandos, and we are seeing. Oh my god! Wait. Ah, there we go. Oh wait. Wait, hold on. Does it? I mean, Atlas location. Hold on. Atlas locations. It would be this array, which is filled out. Okay, so it has as many entries in it as there are textures, and then we go through and fill it. Oh, we fill it out in the same order as we. Okay, so that's why it works. No, we don't actually have to do anything else. There, this just works. Okay, well, good. Yeah, that's memory equals, that's string start, that's the enum, this is mapping from file names to IDs, and this is using the Atlas. Okay, well, and I guess I mean I've done that. Add IDs to Atlas locations. Now another thing I realized is that I have this 3-line pointer shift that could just be 1 line. Somewhere wherever we are reading a Sprite files, yeah, like here. So we could just have this be chunk equals like, well, we could have it be this thing, but we could also just cast chunk to void star here. Yeah, there we go. That's all you really need to do to move it. let's have two different ones on the atlas. How is our atlas? Here. Yeah. Oh my god. Okay. Alright. Well, one thing we'll definitely need is to be able to mirror these. Well, actually, another thing I realized, right, is that we don't actually need world units. Because our source pixels are so large that we could just use the source pixels as the world unit. So this half span right here could just be a half span in world unit and in source art pixels. And then every sprite could be just scaled the same amount. Because we're not going to be upscaling different, like we're just going to have a different sprite if we want it to be larger. So let's do that. So what does that mean? By screen pixels specifically. Okay, so if the half span is in source pixels, then window width, we still need this. This world unit per pixel becomes source pixel per screen pixel. Yeah, so half span is in source pixels. Yeah, so this still makes some sense. Right, like 100 by 0.1. Yeah, I think that makes sense. Alright. So what does that mean for the shader? Let's see. Oh my god, what? Close other editors, HLSL. There we go. Yeah. Well, we need the screen position, for sure. Which is passed in I mean, it's passed in as a like the world unit, which is the source pixels in terms of scale. And this one is 4444, so it's slightly off center. Dimensions. So dimensions we don't actually need. Okay, so let's remove dimensions. And of course we have to remove them from like 13 places now. Yeah, the screen top left, it's not actually top. Yeah, that's another thing I have to do. Screen pause. I mean, let's just call it screen pause for now. That's ambiguous enough. That's what it's called here. Text pause and text dim. I mean, this is text top left. This is Atlas top left specifically. Maybe that's what I should call it. Atlas top left. And Atlas dim. I mean, it's not the dimension of the atlas, it's the dimension of this texture in the... Text in atlas, top left. text in atlas dim. There we go. Okay, I might as well just call them the same things here. Okay, so what is that rect instance? It's not anywhere to be found. Struct rect instance there. Okay, so that's a v2 screen position, whatever that means. v2, well, I mean, text and atlas top left, text and atlas dim. Alright. Screen position, so now screen position is just this first. So we don't need screen dimensions. Just the first set of curly braces is the screen position. Now, this is text in atlas top left. Text in atlas top left. Well, I mean, we do kind of just want to assign a rect to that. I mean, well, okay, text in atlas then. So this is gonna be rect text in atlas, like that. Okay, now here, this text in atlas thing needs a dot, and, of course, lowercase. Alright. So this is us moving the screen position. Screen pause. Alright, so that. Alright, so we have some errors here in the shader, but no errors here, seemingly. Alright, so what's the shader gonna do then? Position and camera, position and clip. Dimensions and clip. Well, screen dimensions are actually the same as the texture dimensions. So that should be sufficient. So I don't know, what's this gonna... Alright, yeah, so this seems about right, actually. Just scaled up. Okay, they are blurry though. Although... Are they? I mean, let's look in render doc. Let's look at how that works out. Capture frame, zoom in. Well, they are blurry, but I mean, we are scaling it up by a non-whole sort of number, so I guess this is actually it's what you'd expect to see. I think this is working as intended. And with arbitrary scaling, you'd have to have some blurriness like that. Of course, with exact scaling, that wouldn't be a problem. But then you need exact scaling. Actually, what would that look like? Well, the half span has to match the resolution, essentially. So if the window, like however many pixels, yeah, the camera half span x should just be half of the window width, and then we'll get 1-to-1 scaling. We don't actually know what... I mean, let's just do it in a kind of hacky way. So we we figure out window position, window size somewhere in here. Yeah, so at this point we know what it is. So if we just set this to window width divided by 2, let's just assume it's even. Then, okay, so this is 1-to-1. And this is how big the art is. Now, if we divide by, so that's 1-to-1, if we divide by, and whatever this number is the upscaling. So this is like twice, 4 times, 8 times, okay, 8x, this is 8x. Is 4x. Yeah, I think the actual game usually runs somewhere between sort of 4x and 8x. I mean, 2x is definitely not. Like, you can barely see anything. It's like super blurry. Yeah, so at least 4x. You need at least 4x to be any kind of playable with exact scaling. Of course, we can have arbitrary scaling, but this is 5x, for example, and still looks fine. Yeah, so we don't need to be constrained by like having to have exact scaling all the time, because non-exact looks fine as well. Okay, so let's not worry about that. Yeah, it should probably be somewhat big for now, so you can see things clearly. Okay, so let's commit that. Screen position text in Atlas. Yeah. Yeah, this is just, yeah, probably should align it, since it was aligned before. Although, there seems to be some, alright. Apparently Git thinks that we've added this space specifically. Okay, what's this? Remove trailing white space. Okay, that's a one-liner. Yeah. Alright, so we are using use source pixels as world units. Okay. Alright, so we know we need to be able to flip the sprites when, you know, moving to the left. So flipping the sprites is just switching out the UVs on the horizontal axis. So like, let's see, if we were to always flip the sprites, that would be this UV, well, it goes from 0 to 1, and we want it to essentially go from 1 to 0, so what, like -1? This UV equals this UV -1 times -1. What? No, this UV is declared. What are you talking about? What? shader tools. Shader tools isn't capable of shader tooling today. Okay, well, I mean, that did flip them, just not. It flipped them across the X and across the Y. So that, yeah, that's what's happening here. So it's looking, yeah. Because we will need to flip the X, actually. Well, I mean, we could also just, you know... Well, we know that the X would be... So 0, 0... well, hold on. No, I had it. I pretty much had it. Hold on. X minus 1 times negative 1. That. This UVX equals that. Okay, well, there you go. We flipped them. Why? Wait, hold on. So if I don't flip them, we're controlling the commando. If I do flip them, we're controlling the Lemurian. The sprites themselves change. Because the position... Oh, because it refers to the atlas, not the region inside the atlas. So we need to do this transform like here. So like... So like that. Just pull it out of there, then flip the X, and then do the scaling. Okay, there we go. Okay, so that's the idea behind flipping them. But we need to do this only when we need to flip. So each rect should presumably have some information passed in regarding its orientation. In this case, orientation is just, well, it's not rotational orientation, right? It's like specifically whether it should be mirrored. So like if mirror, wait, mirror is a keyword? If, well, first of all, does this work? We can do if 1 and if 0, presumably. Yeah. If should mirror X, I guess. If mirror X, then do that. Okay, so what's mirror X? Mirror X should be passed in, like here, int mirror X. Okay, it still doesn't like it. Undeclared input dot. Okay. Compilation failed, no code produced. VS input missing mirror X. What's HLSL mirror though? HLSL mirror. something to do with texture sampling, or... Okay, is it here? No? No, it doesn't look like it. Well, alright. Whatever. Okay, so this should still not work because we're not passing this in, so I need to add that. What a waste of time, this just synchronizing these things. So mirrorx format is... What formats are available to us? Sint. I mean, I made it an int. Like I mean, we really need it to be like a byte, you know, char. What are the HLSL data types? Data types, HLSL, scalar, vector, scalar, yeah. Bool. Bool is like, well, how am I supposed to pass that in if I don't know how big it is? What's a bool? We don't know. Okay, well, int, whatever. Int is 32-bit signed. Yeah. So R32 sint. That's what it is. Offset off. Mirror x. And it's per instance. Int mirror x. Okay, so mirror x is gonna be... Okay, we failed. Has Sprite 28, which is less than the minimum Sprite logically expected from the current layout 32. Okay, can we convince HLSL, I mean the compiler, to just get this rect to do the right thing, essentially? I mean, this rect instance thing, that's kind of a platform specific. Yeah, we're only constructing it to be passed into DirectX. But what I want, I mean, it's platform specific, but like, you know. So screen position, texture, mirror. Can we like pack 8 or something? Because I think that's what it's doing. Where is the pragma pack again? It's that. Pragma pack. Pragma pack. Yeah, because this is 8 bytes and this is 16 bytes. And it expects 32. Well, I mean, it's what's 2 plus 4 plus 1, so 7. And we've got 7 4-byte, so that's where 28 comes from. It's 7 4-byte things. Pragma pack 8. Okay, so if we pragma pack 8, that is that gonna... Oh, is it 16? Strike 28. Okay, so I kind of just wanted to insert some padding. At least 16 bytes aligned. Let's find out. No, so that packing doesn't do what I expected to do. So, alright, well, if it doesn't do what I expect it to do, I might as well just insert padding myself. And U8, bad. And how many? We want 4 bytes of padding at the end there, I'm pretty sure. Okay, so that is passed in correctly. Do we? It seems to. Yeah, it seems to be working correctly. So then, can I just? Okay, so this is where the rects are passed in. Well. Alright, so then, like, mirror x is 1, well, true, you know. Okay, well, yeah, so that works. And now I just need to do it whenever we are moving to the left. So, like, here. Okay, so rect, storage. Well, that's, yeah, I mean, yeah, we're probably not going to be modifying them this way. Although that is a question, like, how are we going to be... So right now, I don't... Right now, rect instance is basically the only place where I have information on where things are. And it contains specifically information required to draw it. So we might as well just keep it there. Yeah, I'll gotta think about that. So left means true, and right means false. So it's just that. Yeah. Well, I mean, it does flip around quite a lot, because it like teleports to the left a little bit. Which is expected. I mean, it's just whenever you mirror the X, you also need to like move it, unless it's symmetrical. Well, I suppose if we're referring to the center, then no matter which way the UVs go. Well, no, wait, look, the center is here. So that's how it flips around. Let's see that in action. Okay, so the screen pause X, comment that out. Let's move them further apart. Like 40, 20, something like that. Okay, so it should be flipping around wherever the center happens to be, which is like here. Which does make sense, yeah. I mean, so to avoid that, we need to somehow tell it that there is an alignment, and that alignment changes whenever you flip, and when you draw the thing, you need to draw it in accordance with that alignment. Yeah, well, so let's just say the alignment is like 0. That means when you flip, the alignment, the X alignment specifically. If the alignment was 0, then once you flip, well, this specific it's almost like the position, well, the position, well, no, the position of the center actually does change. Huh. Interesting. It's like with this sprite, it expected to flip here, as opposed to here. Which means the position of the center changes the position of the... Well, the rectangle, like this is where the rectangle is, and you kind of expect it to be here after the flip, because this is where the flip happens. So this needs to be marked somehow, and then the flip needs to happen around that. And that would just work automatically, I guess, if the position of the rectangle, which right now refers to the center, actually referred to, at least on the x-axis, it referred to the position around which you expect the flip to happen. Okay, well, how do we even move that? Okay, so input gives us the screen position. Screen position of the center of the rectangle. Alright, so let's say we have some kind of offset, which is like, I don't know, 10, like offset from the top left, like 10, 0. I mean, we only need offset x, right? Float offset x is, let's say, well, it's like 0 now, right? Although, well, I mean, if this is offset from the left, then the position refers to, well, I mean, that is a good question. What should the position even refer to? Like, what is the position of a whole rectangle? Like, right now it's the center, but is that really meaningful? Probably not. We should probably just have a reference point within each sprite, and we just say, well, this is the position. Like when you say this sprite is located at these coordinates, that pixel is the pixel whose position we're referring to. I guess the center of that pixel. And well, right now we only need that on the x. So, alright. So let's say it was 0 from the left. So we're referring to the very edge of the sprite there. Well then, so this is the camera half span, this is the position and camera space, so input screen position. We are trying to refer specifically to the edge of the sprite. So this is the position of that in camera, position in clip, dimension in clip, scale in clip, position in UV, scale in UV. Yeah, so that's all fine, I think. Okay, so this vertex ends up being scaled and moved. Yeah, except that at this point we are kind of essentially saying that yeah, at this point, we are relative to the center. So we haven't actually, we need to use the offset. So at some point before this, we need to use the offset to say that, well, we know that all these transforms are going to happen in such a way that they're referring to the center of the sprite. So if you want to move it, so offset 0, float, offset from center. There we go. So offset 0 means offset from center is half the width. That. I mean, well, negative, right, to the left. And offset 1 would be, well, so basically this plus offset x. So this is the starting point. And if you subtract half width, yeah, if you subtract half width, then you get the offset from center. Okay, so camera half span offset, float to pose offset. Well, yeah. Offset position is float to input screen position x. I mean, screen position sounds like it's pixels, but maybe I should call it like world position or something, like, I don't know, or just position. So it's position x plus offset from center x, and then input position screen position y. Yeah, should probably just call it position, like that. Yeah, screen pause just becomes pause, like that. Okay, well, I mean, so this is offset position. So input position should be replaced here with offset position. Let's see. So we should be flipping around the left edge now, which I think that's what's happening here, yeah. So if we set the offset to like 5 or 4 source pixels, there should be source pixels, and we should be flipping around, well, this is like 4 source pixels in. Okay, what are we flipping around? Still the left edge? Interesting. What? Why? Half. So that's offset. I mean, it should definitely do something. Wait. Is it? Is this? It's moving to the. Okay, I'm clearly not understanding this. It is flipping around the left edge. Okay, was it flipping like this before? Like, did we do anything useful? So what if I just use input position? Okay, so this, now we're not using offset. Not using offset at all. So it is flipping around the left edge. I mean, no, it's it's not flipping around the left edge, it's flipping around whatever, yeah, it's flipping around the center. Yeah, I was interpreting the flip incorrectly. Okay, so it is flipping around the center here. Okay. Okay, so I think offset position, for what it's worth, is doing what it's supposed to be doing. It's just, it needs to respond to mirroring. Okay, so let's say offset position is 0. Which will move, so like left edge is here with the offset, and then we go in and we, without the offset I mean, and then we replace this, so we actually use the offset position, and it should like move to the left. Yeah, so it moved to the left by 4 pixels, 1, 2, 3, 4. Yeah, this seems correct. It moved to the left, so okay, now it just needs to respond to mirroring correctly. Well, so if we're mirroring, then what that means is that whatever offset from the left we had now becomes offset from the right. So like if mirror x, then offset x is input this dimension thing. Minus offset. So like something like this. Okay, some well, it definitely did something. Okay, so if it's flipped, and then the position. So if offset x equals texture dimension x, then once you flip it, it becomes 0. So if you were normally drawing the sprite sort of offset to the right by its dimension, and once it flips, you wouldn't be offsetting it at all. Meanwhile, with the offset x equal to 0, which is supposed to mean left edge, offset will become equal to texture. So that's why it's moving to the right, because it's positive. But actually it's supposed to be minus that. Okay, so if it was equal to texture dimensions, then, and you were flipping around that, then it's supposed to become, if you're mirroring around that, then it's supposed to become texture dimensions. So hold on, these should be flipped then. So like 0 becomes negative texture dimensions. Texture dimensions become to offsetting it. Becomes 0. Wait, am I thinking of this correctly even? So offset x 0 means we want to flip around the left edge. So the left edge should remain stationary. So offset 0, so normally when it's looking to the right, in case of the commando sprite, when it's looking to the right, the offset is nothing. When it's looking to the left, it moves to the left by texture dimension. Okay, so I think that does make sense. Okay, so this edge is the thing that's supposed to be stationary, which is like, I think that, yeah, that's how it's working out. Of course, it does kind of teleport. Which, I mean, I think the actual game might actually work like this. Because sprites, I think, do teleport a little bit when you switch directions. Of course, this doesn't have to work like that here. So if the offset is, let's say, 2 pixels, then what is happening exactly? Hold on, let's make it like 6 pixels. So I think that the whole texture is 9 pixels total. Okay, what if I do make it 9 pixels? What if I do make it this number? Texture dimensions. That's like... Huh. Hold on, what if I make it more than that? Oh, it just disappeared. Okay, well... I don't think this is doing what it's supposed to be doing. Like, yeah, it's flipping, but it's flipping in a weird kind of way that I don't really understand. Okay, so it used to be here. Okay, so this I do understand. So that is the left edge. And we give it a bit of offset. And normally we don't offset it. But when you flip it to the left, we do offset it by the texture dimension. So now the left edge is here. It's moved over by the texture dimension. Okay, so what happens here? So if we set the offset to be half of the texture dimension, well, half texture dimension, okay, so normally what happens is it gets offset to the right by half of the texture, so it's like we're referring to some position. It'd be helpful to have a grid, actually. Well, while we don't have a grid, let's just put the thing to the center. Into the center, on the x-axis at least. both of them. 0 on the x and minus, like, minus 10 or something. Y. I mean, they are both being offset by the same amount. Okay, so 0 offset means this, apparently. Okay, so they're both centered with 0 offset. Okay, so that's the leg, that's the right leg. Now, if I set the offset to half the texture dimension, it moves to the right. Okay, so that does make sense. It moves to the right by half the texture dimension. That's sort of by default. Which is already that's not really what you want, right? I mean, even with offset 0, actually, you want it to be in the center of the screen. I mean, you want, with offset 0, you want the left edge to be aligned with the center of the screen. Which, like, is it? No, the right edge is aligned with the center of the screen. By the looks of it. Why? Yeah, this is where 0.5 is. So the right edge is aligned with the center of the screen. The right edge? What? Why? Hold on, am I subtracting something wrong or what's going on there? So I'm saying offset is 0. Wait, oh no. So we're not mirroring. So offset remains 0. Offset from center becomes minus half of the dimension. So offset position becomes whatever the input position was passed in, which is like 0, minus that. Yeah, so what's wrong with that? Mesh viewer. Okay, so we go in here, input says position is 0 on the x, yeah, offset from center is minus 4.5, which is half of 9 in the negative direction. Oh wait, so we would normally draw it in the center, but if you want to draw it on the left edge, you actually need to move it to the right. Yeah. So I did. Which... Okay, this is wrong. if you no, it would normally be drawn at the center, but offset 0 means we want to draw it on the left edge. So we need to have a positive offset from center here. Do we? Yeah, we need to move it to the right, essentially. So that. And again, if offset was equal to texture dimension, then you would normally draw it at the center, but you want to draw it on the right edge, so you need to move it to the left by half the texture, which is what would happen here. Okay, so let's compile that. Go to RenderDoc, launch the application again. Alright, so where is our 0.5? So there is the 0.5, the left edge is aligned now. Okay, at least that part's working as intended. So offset 0 means the left edge is aligned, so let's verify how other offsets perform. So offset is a quarter way through the texture. Okay, where's 0.5? 0.5 is here, which does seem to be a quarter way through the texture. Okay, so it does. Okay, and now the right edge should be aligned. Yeah, so that's the right edge, and it seems to be aligned with the right here is 0.5. Okay, so that's the right edge, and it's also aligned. All right. So at least the first part is working as intended. Now mirroring. Well, let's see what happens with mirroring. So this is the right edge being aligned. What was that? What was that? Rectangle flash 112. Let's just let's go here. All right. RenderDoc. All right. Okay, so it's flipping around the right edge, which I think is what it would mean to have an offset like that. When you move to the left, that part stays stable and rotates around that. Yeah, so let's set the offset to like 0. Now it should rotate around the left edge, which it isn't. It's still rotating around the right. It is compiling, right? Okay, so interestingly enough, it still rotates around the right edge. Even though the offset, hold on. Okay, so there's two parts. There's two parts to the offset. There's throwing the thing in the right location, and then there's flipping, which is different. Is it different? Well, if you want the right edge to be aligned, well, let's say if you want the left edge to be aligned, as is the case here. So right now the left edge is at the center. Okay, so capture that, and then capture this. Okay, the left edge should be at the center. Yeah, 0.5. Yeah, 0.5 is here. Left edge is aligned to the center, as intended. And what I intended to happen is when you mirror it, there is some negative offset involved with that mirroring. Maybe this is the wrong place to do it. Come to think of that. Think of it. It's like you want to draw the left edge at the center of the screen. So, like, if you just don't do this, so this is the center of the screen, and this is the center of the screen. So this is what happens when you just don't do anything. Now, if the left edge is supposed to be aligned, that means the offset needs to be negative. Because the whole thing needs to move to the left. Which it would become negative here, the offset would. And the offset from center would become negative . Yeah, so the offset is negative texture dimension. Well, let's see. Let's look at this capture. Yeah, so it moves like way to the right for some reason. Mesh, instance 1, debug. Okay, so there's the offset, it's -9. Offset from center is 13.5. Okay, this offset from center thing. Okay, that's probably where the problem is, right? Because when we're talking about offset from the left edge, to get offset from center, well, 0 means -½ texture dimension. Wait, no, that's not what it means. 0 means you need to move to the left by that amount. Because we are referring to the normally the position refer to the center. We want it to refer to the left edge, so there needs to be a positive offset there. But when we're mirroring, offset suddenly refers to the right edge, essentially, as opposed to the left edge. So the offset position, so like here is where the conditional is, I guess, and not here. Although it could, shouldn't we be able to put it there as well? So it's on the left. and we're mirroring, so it's, so once flipped, it's, well, let's see. All right. So let's remove that. So this is the offset from the left edge. This is the offset from the center. And we've verified that that part at least works as intended. Now offset position. Well, I mean, it works as intended for when you're not mirroring. When you are mirroring, it doesn't. Actually, right, we can probably debug this easier if I can just if I just mirror the Lemurian. Well, actually, I don't even need to do that. I can just put the same texture on both of them and mirror one, and let's just see what happens. Right, so this is wrong because the left edge is supposed to be aligned in both of these, not what's happening here. And if we just, okay, so right now we're not doing anything with mirroring other than just switching out the texture. So like if we remove this, yeah, if we remove this, now we're just not doing anything at all with mirroring. So it's the same two textures. Now this part switches texture coordinates, so it flips, and the only other thing that I need is to just offset the X correctly when mirroring. Which means, in this case, it would mean moving to the left by texture dimensions. So minus texture dimension is the correct offset, except that's referring to what? Yeah, it's this offset from center. So when we are mirroring offset F, I guess it's easier to think about as when we are mirroring, the offset X refers to the right edge, not the left edge. So offset from center is that when it's the left edge, but it's a different thing when it's the right edge. So you subtract offset X. So you would normally draw here, but offset 0. So offset 0 means you need to move to the right? So it's but if we're referring to the right edge, that means we need to move to the left. So it's a negative. It's a negative offset from center. So, yeah, so offset from center needs to change, and specifically needs to change, it's like if input mirror X, then this is different. It's negative, right? It's like that. So can we just multiply it by -1? Yeah. So this seems correct. Alright, so let's try different offsets. Let's do that offset. Okay, so this is the right edge. The right edge is supposed to be aligned now. Which it is. This is supposed to be the center. So like the center is aligned. It's flipping around the center. Okay, so this seems to work. Yeah, this seems to work. Of course, this needs to be passed in from somewhere. And we're gonna need offset y as well. So might as well just do that. Float to offset offset. So let's just remove offset x. So offset x becomes offset x like this. Well, honestly, offset from center. It's the x specifically that needs to flip. Input offset. Yeah. Plus offset from center. Input pause plus offset plus offset from center. There. Okay, that's unused, but that's fine. Now, yeah, we need to describe this, because of course we do it. 1638, oh boy. Alright. That's gonna be the last thing for today. Screen position offset. That's fine. Offset, that's fine. So the position offset, text atlas. Right. Now we go to rect instance and it's v2 pause, v2 offset. Like that. That's fine. Yeah, that's fine. So offset is going to be 0, so it's going to be aligned to the top, or it should be aligned to the top left. Well, let's see if it even works. Alright, so that does work. One of them is flipped, one of them is not. So let's look at in render doc. Where we are. Alright, so what's this? Okay, so 0.5 is actually here. It's 0.5. This is 0.5. Okay, what was our positions again? 10, 10. Okay, let's place one of them at 0, 0. Move and like, that one's fine. Minus 20 or something. Just move them down. Alright. Okay, so the first one is at 0, 0. The one that's not mirrored is at 0, 0. Okay, so this part should, yeah, so okay, 0.5 is apparently here. Interesting. Yeah. That's what we want. Alright, let's go to render doc again. Save this. Take a look at that. Okay, so that's 0.5 as expected. Okay. It's aligned to the top left. Yeah, that's fine. And when it flips around, it flips around the left edge because we've set the offset to be the left edge of the sprite. So wherever we are parsing a sprite, like here, we should probably get sprite offsets from the source art, probably. Because we have the ability to just do that. Alright. Well, we have character moving around, kind of. Very slowly, but we've got it. Well, let's see. Pull down that struct. I mean, maybe I should just pull this out as well then, so I can find it. So it gets displayed in the debugger and everything. Yeah, pull those out. This is now slightly different because we changed the input. Yeah, those are just temp. Yeah, all of this is like temp stuff, so I can see. Okay, what do we have here? Change some inputs. Implemented mirroring and and offset. Yeah, this seems fine. All right. Implement Sprite align, no offset, mirror ring and alignment. Okay. Alright, well that's all for today. Thanks everyone.